Okay, so today we're gonna do 2.5, the transpose. So definition 2.5.1, excuse me. All right, so AB M by M matrix, then we are using T, right? So we are using first letter T from the transpose here. So we are reading the transpose of A. And look, we know that this is, the first one is the row, second one is the column, right? But then look, they change that, interchange, this is row, this is a column, right? That means transpose, look, ij entry, switch over ji entry, right? So let me write down, let me finish this definition. So the ij entry of A becomes the ji entry of transpose A, right? So think, make row to column. That's the transpose does. All right. Okay, let us do this. Calculate. Transpose of A or A equal to 1, 3, 2, 5, -6, 4. Okay, we change it from row to column, right? So let me do this way. This one will be column. 1, 2, -6, and 3, 5, 4, second row. Yeah. So basically, look, we have a 2 by 3, and then we are using 3 by 2, right? So 3 by 2. Okay, ij entry becomes ji entry, right? So, all right. Okay, now, properties. Let's talk about the properties. Properties of the transpose. A matrix. Okay, let me see here. So let A and B matrices whose size they are appropriate for sums. So we have to have the same size, right? When we add. And product, we have to check the size too, right? Whether the inner has the same, right? Product. Okay, they met all the qualification. All right, so if we have that, the first one, A transpose over transpose, right? So this one gives us the A. Okay. Second one, let me write down everything and I'm going to show you in the matrices, right? Okay, we have A plus B transpose, then A transpose plus B transpose. And then C, we have R is a scalar. Scalar is the real number. Are there? Or A to the T power R. Always when I sound R, like R, makes me this sounds. R. Okay, D. And AB transpose, which is B transpose, A transpose. Okay, let me show you the example, everything. Okay. We have A. Let A equal to A, B, C, D this way. Okay. A transpose away. A transpose. Okay, then we say that row will be column, right? Okay, so A, B, and C, D. Now, we want to make a transpose A and transpose again, right? Then we are looking at this, and then we want to make a transpose. So that is row will be column again, right? So that is AC, BD. What is that? This is A, right? Okay, so we can show that, this is that, right? Thus. Okay, second one. Let me see, we don't remember. Copy. All right, let's talk A equal to A2, A2, 1, 2. 1, 2. B equal to 3, 4. Okay, so we have A plus B, same size. So 1 plus 3, 2 plus 4, right? Okay, that is 4 and 6. Okay, now we want to make a transpose. So this one we have a column, right? So since we have a column, we can make a row, same thing, right? So we will use 4, 6. Okay, now transpose of A. 1, 2 as a row. And transpose of B. 3, 4. Okay, now can we add them? One, two. 3, 4. So that is 1 plus 3, 2 plus 4, which is 4 and 6, which is the same as this, right? Okay, so we can conclude. All right, third one. So we have this one, the scalar times A to the transpose, which is, we keep the scalar and then A transpose. Here. Okay. Let's R equal to 3. Let A equal to 1, 2. Then we get 3, 1, 2, which is, let's make R times A. Okay. That is 3 and 6. Okay, let us make R A transpose. Column, make a row. Okay, so this one, we can factor out the 3, then we have 1 times 2 there. So that is 3, 6. 3, 1, 2, which is the same as a 3, 6. Okay, that is R, and this is a transpose. Let me denote it this way, right? So this is 1, 2. Yeah. So R equal to 3, 1, 2 with the row is A transpose, right? So that is 3, 6 here. 3, 6 here. So that is R A transpose of R A, right? Okay. All right. The last one we have this. Okay. Okay, so A equal to 3 by 3 matrix. So we have 2, negative 1, 0, 1, 0, negative 2, negative 3, 3, 1. And we have B equal to 3 by 2. So that is 3, 2, 3, and 1, negative 1, 0. Okay. We want to make a product, AB. AB. Let's check the size, right? So it's a match, they agree. So this will be 3 by 2, right? Okay, let us multiply this way. So let us do that. 2 times, too much, right? 2 times 3 plus 1 times 2 plus -3 times 3. Okay, now second row. So -1 times 3 plus 0 plus 3 times 3. Okay. All right. Third row. 0 plus -2 times 2 plus 1 times 3. Yeah. Okay. Please correct me if I make a mistake. All right. Okay, thank you for the message. First row, second column. 2 times 1 plus 1 times -1 plus 0. I'm not rushing so that I try not to make a mistake. Okay. Second row. And first one with the first one, second with the second, third with the third entry, right? So -1 times 1 plus 0 plus 0. Okay. And the last one. 0 plus the -2 times -1 plus 0. Okay. All right, there will be, can you please calculate? Your turn. I did a lot of work. Come on. You should do the work too. That's fair, right? Okay. Direct message, thank you very much. So, yeah. Let me using that. -1, 6, -1, 1, -1, 2. Okay, now we want to know about transpose of AB. So transpose of AB. So row will be column in the case. So -1, 1, 6, -1, -1, 2. Okay, now we want to know about transpose of B. B is here. So transpose of B, which is 3, 1, 2, -1, 3, 0. Okay, now A transpose of A. I need A. Okay, so A is that, and transpose A, which is 2, 1, negative 3, negative 1, 0, 3, 0, negative 2, 1. All right, let us do this one. Transpose B and transpose A, product of 2. Yeah, so we are doing this one. This one? Copy. All right, so there will be check the size, 2 by 3, and this is the 3 by 3, right? So they are match inner, right? So we will get 2 by 3. Okay, I have to write down, otherwise I get confused. I have to have right order like that. Okay, copy. And then that. Oops. Copy. Okay, let us do this. Okay, be careful when you do that, right? So I'm gonna be careful. All right, so first entry with the first entry, second entry with the second entry, third entry with the third entry, right? We multiply and add them. So 3 times 2 plus 2 times 1 plus 3 times negative 3. Okay. Now, second one. So 1 times 2 plus negative 1 times 1 plus 0, right? Okay. Okay, now first row and second column, same concept. First entry, second entry, second entry, third entry, third entry, you multiply and add them. So 3, negative 1 plus 0 plus 3 times 3. Okay, now second row. So 1 times negative 1 plus 0 plus 0, right? Okay. Thank you, the message. Okay, we finish second column. How about the third column? Okay, now 0 plus 2 times negative 2 plus 3 times 1. Ready? Your turn. Don't go anywhere. And second row with the third column. So 0 plus negative 1, negative 2, 0. Okay, can you please calculate? Two by 3. Wow. Thank you, the message. So negative 1, 1, 6, negative 1, negative 1, negative, it's a positive 2. Okay, let's check it out. We don't know, right? So, okay, the number negative 1, 1, 6, and negative 1, negative 1, 2. Is it same as This one, let's bring this one here. Yeah. So this is actually same as that because this one transpose of B and transpose of A, right? So we can conclude, therefore, so AB transpose of AB, which is the same as transpose of B and transpose of A, right? Okay, those are properties. All right. Okay, we have another definition. So definition, symmetric and skew symmetric matrices. So M by N, A equal to M by N matrix is said to be symmetric. We said symmetric if the original matrix is the same as the transpose of A. That's a symmetric, okay? And they say that it's said to be skew symmetric, symmetric, if A equal to, we have a transpose A, that's a symmetric, right? Transpose of A and negative, then skew symmetric, okay? Terminology. Symmetric. Okay, let us do this. Let A equal to 2, 1, 3, 1, 5, negative 3, 3, negative 3, 7. Show that A is symmetric. Okay, then that's it. We need to show that only transpose over, right? Okay, so that is show A is transpose over, right? Okay, transpose of A, which is row B column 1, 2, 1, 3, and 1, 5, negative 3, 3, negative 3, 7. Oh, this is a transpose of A, right? But we get the same as A, right? Can you see that? Yeah, so we can conclude. Yes, A is symmetric. Since A is same as transpose of A, right? Okay, now show that A is skew symmetric. Second part. Let A equal to 0, negative 1, negative 3, and 1, 0, negative 2, 3, 2, 0. And show that A is skew symmetric. Okay, so we are showing that transpose with a negative sign, right? So, okay, so A equal to negative transpose of A. All right, so let us do this. Transpose of A. That is row will be column. So 0, 1, 3, negative 3, 1. I'm sorry, 0, 2, negative 3, negative 2, 0. Okay, so we can say that so A equal to negative transpose over A, or we can say that also negative A equal to transpose over A. All right. So there will be, then we can say that this is negative of A, right? Because scalar number 1, we multiply, then we get the negative part, right? So yeah, is okay? Very good. All right. Any question? Okay, let's keep doing that. Identity and inverse. So identity. And inverse. Okay, identity matrix. So we are using identity matrix. So we are using first letter I as identity matrix. Okay, identity matrix is a square matrix, so they using, instead of m by n, we are using just I sub m, because a square matrix means that row is the same as column, right? Same size of row and column. So for instance, 1 by 1, 2 by 2, 3 by 3, and so on, right? Okay, now 1 by 1, how it looks like? 1. 2 by 2 looks like 1, 0, 0, 1. And 3 by 3 looks like 1, 0, 0, 0, 1, 0, 0, 0, 1. And we knew that 4 by 4. Okay, say everyone. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Whew. Right? Okay. Now, another vocabulary I never heard. All right, so they say the Kronecker symbol. So identity matrix, IJ entry, right? It's the same as In Greek, we are using this one as delta. This is a lowercase. And they're using delta ij, sub ij. And they're using that one as chronicle symbol. Too many names. Okay, what does it do? They have delta sub ij equal to 1 or 0. So 1, that happened, I and j is the same. 0 if ij is not the same. So we might think this way, right? So think, we can say that delta 2, 2, they are same, which is 1. Delta 2, 3, which is 0, right? Because in that case, I equal to j. In that case, I is not equal to j, right? Okay, now. Let us do this one. Inverse. Definition. 2.6.1, the inverse of a matrix. So a square matrix. Do you know to this way? So square matrix. So size of a row, size of a column, same, right? Okay, now. We say that it's the inverse. A is said to have an inverse. And the inverse is notation, this notation, right? -1 as a power like that. If and only if. So we know that this one we do make a shorter, like a IFF, right? And
is the exponent on that a, is that a -1 or?
-1, yes, correct.
Okay, thanks.
-1. Okay, so -1. Then we have A inverse A equal to identity. And I said identity, we're not using m by n in the case because we know the same size, which is a square matrix. So we are using just n, right? Okay, so we called matrix A is called invertible. Inverse and invertible. Okay. All right, so let us do this. Theorem. Two 2.6.1 uniqueness of inverse. Okay, suppose A is n by n, make it shorter, A equal to n by n. Yeah, we know that this is a square matrix, and such that inverse, let me write that, inverse, and then notation, which is like that, right? Exist, then there is only one such inverse matrix. There is not more than one, only one, unique, right? There is a uniqueness, so only one. Uniqueness. Okay, such a inverse matrix that is, we have a matrix B given any matrix B such that AB equal to BA equal to identity matrix. All right, since product of two matrices given to the identity, then B must be inverse of A, right? So we are denoted this way. Then B equal to inverse of A, right? Okay, let's prove. Okay, we have assume everything. I equal to n by n, identity matrix, we know that. And let A equal to n by n, also B equal to n by n matrices, and such that inverse exists. And AB equal to BA equal to identity. Then what we are trying to show, only trying to show this one, all right? Want to show B equal to inverse. B equal to inverse, all right? Okay, now we're gonna start this one and we're gonna show this one, all right? So let's start. Inverse of A, okay, that is, it's okay, we can make a inverse of A and identity there, right? It's the same, equal sign, right? Then this one, this is condition, we can have that, so we can have that identity, so we can say the inverse of A, then AB, because we said AB equal to identity, right? So replace identity as AB. All right, then that will be associative in the multiplication, we can have that. So like this. Okay, then what is this? We knew that since inverses exist, so we know this is identity, right? Okay. Identity times B, we can absolutely express as B, right? Yeah. Anything identity, we get the matrix back in product, right? So we get the B. So A inverse equal to B, we prove, right? So thus Inverse is unique in the case. Only that. All right. Okay. Let us do this. Let A equal to 1, 1, 1, 2. Show 2, -1, -1, 1 is the inverse of A. Okay. How? We multiply together, then we must get the identity, right? So let us show that. Okay, so we have 1, 1, 1, 2. 2, -1, -1, 1. Okay, now we have to do that. Multiply. So 1 times 2 plus 1 times -1. And okay, since we don't have time, let me not doing that. And second row and first column. So 1 times 2 plus 2 times -1. And first row and then second column. So we have 1 times -1 plus 1 times 1. And second row with the second column, which is 1 times -1 plus 2 times 1, right? Okay, your turn. What do you get? Ugly. Do we get this? 0, 1, 0, 1. Thank you very much, direct message. Okay, very good. All right. I was rushed. Any question? Otherwise, we don't have time, so I was rushing. You guys okay this? Okay, then we're gonna talk about more inverse, how to find inverse of A next time, right? So continue with the inverse next time. But I wanna finish this one, all right? Okay, thank you for coming.